Next, we've got a speaker who has been, among other things, a professional makeup artist, but didn't get the job at McDonald's. He built his first Mac from secondhand parts, a soldering iron, and a book, learned to program using bubble cards. Has anyone in this room seen a bubble card before? See like one hand. And also, eventually used toggle switches. So once the internet captured his imagination, it was all over, and he's been trying to keep it user-friendly ever since. Please welcome to the stage, Ken Easson.
Well, thank you very much, and welcome back. I'm going to be talking to you today about hyper-hybrid applications with the Tamagui. Now, I'm going to move over here so I can see people. First question that I want to ask is, get to know a bit about you before I tell you about me. How many here have worked or heard of Tamagui? Okay, one or two hands. I thought that might be the case. How many people here have worked with Expo? Okay, a couple more hands. Excellent. React Native? Okay, excellent. We're getting somewhere. And how about Next.js? Okay, wow, all the hands, which is great. So we're going to look at how the whole ecosystem comes together and why it's a hyper-hybrid and what Tamagui is. My name's Ken Easson. I'm a software architect at Rangle, and I've been all sorts of other things before a software developer. And as I was introduced, one of the big things that I really like to focus on is user interaction. How do we create applications that are usable? How can we have software that people can interact with that works and works well so that the user experience is very, very powerful? But also, on that note, how do we make it cost effective so that the companies don't go bankrupt trying to build the applications that are really, really great? So we're going to look at hyper-hybrid and what that means. And it's just basically a fancy word for universal applications, where one code base serves the web, native, all your different devices, iOS and Android, and possibly others, as well as your back end. And the question is, can we do that? And a possible answer, which we're going to look at the end of the talk, is maybe it's Tamagui. So Tamagui is a framework that sits on top of all of the other frameworks that I asked you about and helps try to bring them together as a cohesive, scalable application platform. Now, this is one of my favorite memes. I hope I don't do this to you today. The idea is that every tutorial starts off with a really clear, I can get started with this. This is great. I know exactly what I'm doing. And then you hit step 2 and you're lost. So what I kind of hope to do a little bit with this session is really, really quickly pound through step 1 and then take a little bit more time filling in some of the texture of what some of the best practices so that we can get to drawing the owl with confidence. So, basic blocks for building a hyper-hybrid application. If I was just doing a talk on Tamagui, this would probably be the last slide. npm create Tamagui at latest. And then there's a quiz. Do you want to proceed? Ooh. And then it gets harder. They would like to know what kind of application you would like to bootstrap. And I would like to quickly pause and say I have nothing to do with Tamagui in terms of its design and development. It's predominantly by one guy, Nate. I'm not going to attempt his last name. He goes by Nate Birdman on Twitter. And the package that I always pick is the production-ready application app with a mono repo, which gets you nicely started. The first one in the documentation says it's arguably too little, and the third one, the final one, is arguably too much. So The first option here, Next plus Expo plus Solido to build a production-ready application, is my go-to for Tamagui. Get, and it runs through its little thing, and you have an application, and you can immediately start. And this is not unusual for a lot of our modern frameworks. I run Yarn native. I open it up in my iOS or my Android device or simulator, and this is what we get. And I think this is how to draw an owl step 1. You might be asking, okay, what do I get out of the box? So one of the things to know about Tamagui and a lot of modern stacks is this one is a very vertical stack. It's built on top of Solido. It's built on top of Expo, which is built on top of React Native. To the right, it's built on top of Next.js. And then all of that lives on top of a DevOps solution powered by Expo and Vercel, which get you into Apple Test Flight and onto an iPhone, and also the Google Play Store and Android. And you might be thinking, that's a lot of tech stacks. That's a lot going on. And you wouldn't be wrong. Because you end up in what I call documentation hell, where you're not going to go to Tamagui to learn how to build a Tamagui application or a hyper-hybrid application. You're going to be going to Expo's documentation to figure out what's going wrong with your Expo libraries. You're going to be looking at React documentation to figure out how to build the front-end code on your Next.js application. Another big challenge with a vertical stack like this is versioning. Because just like your documentation, and this is, I don't want to be too critical of the people that we rely on, the framework developers, but Expo really likes breaking changes. As we heard in our last talk, they're not Angular. They love to break stuff, but there's a lot of support in the community. But this is something we should be aware of, and if you're in the product side, if you're the accounting side, be aware, if you're going to be using some of these cutting-edge frameworks like Tamagui, what you want to be doing is building in time for your developers to learn and ramp up and stay relevant. Make sure that your developers are supported so that they can figure out the bumps in the road. And you will have bumps in the road. And if you're like me, you live for it, right? Figuring out, solving problems, it was what makes you go home and go, I earned my paycheck. This was a good day. I solved a big problem. So this is, for me, a really fun workspace. All right, this is a little bit about what the big blocks are. I want to break this down a bit about what the space you're working in is. Predominantly, you get a mono repo with a big package, which is empty, or almost empty. It's the code that you saw in the Bootstrap, and I call that your static shared code. This is the code you're going to write that's your application. And it all lives in one nice part of the mono repo. Over on the orange, and this might sound ironic because Tamagui is in the name of the talk, I ignore this stuff. So you've all seen the meme. I didn't put it in my slide deck of how to draw a horse by a full-stack web developer. I'm definitely that meme. I tend to be able to do the back-end stuff, figure out the logic and the business cases, but I can't get my pixels anywhere close to perfect. So I let my designer people do my UI. And what that is it's a place where Tamagui as a front-end design system really shines. You get your color palettes, your tokens, all of your designs, and quite a number of components that you can use to build React Native and Next.js with the same code base. Because some of you familiar with React Native will say, hey, I don't use the same HTML tags that I use when I'm writing Next.js. So how do we reconcile that? And we will see that in a few moments. I want to talk a little bit about the Next.js piece of this. We heard it in the last talk. We're going to hear it a lot. SSR comes up all the time. And I would suggest, I see people putting Next.js in the front-end space. I suggest that it's actually a back-end framework. It just uses React on the front end and abstracts that for you. It predominantly is a library that helps you with your SSR and your server-side connections. You can do a lot of stuff in the backend space. And in fact, I didn't even know it had an API until I started working with Tamagui and was stuck with a problem. My native components, even though in the advertising it says it'll work great with SSR, not so much. But I want to talk about that really quickly from a personal perspective and from our customer-facing perspective. Have you ever gone to the cash register with your phone and they're like, do you have your points card? And you're like, yeah, I just need to open the app. About 12 minutes later, you finally get the scanner and the barcode ready, and the lineup behind you is like, really, for 3 points? Right? Our app spaces should be cognizant of the fact that when you're in a mobile device, your application should be installed on your Wi-Fi in your dining room, not loaded from a server where you don't have a Wi-Fi or a reliable Wi-Fi connection, especially in Canada where they love to charge us for every byte of data. So I would recommend that our applications start to look a little bit more like this when we're doing hyper-hybrid. We want to move a lot of our business logic into the API space, a bit more traditional, and load small bits of data to our front end, to our Expo app, and we end up with an application that looks a little bit like this. Our devices are connecting to the API for data when they need it, and that allows our web application to work in a very similar way. I will say this about SSR. My opinion is that it is phenomenal for deep linking. I want to be able to share an app within my, share a link to a colleague or to one of my friends and say, hey, check this thing out. I want to be able to load that page. And that is something SSR does exceptionally well. So let's go back and look at our code structure and actually deep dive into some of the practices around building an application with a hyper-hybrid approach. As we can see, our deep blue is where we're going to write most of our code. It lives inside the packages in the monorepo. We have our app. We have our features and providers that come out of the box. Most of that can go away. But this is where we're going to start building our code. And I've tried to show you that in the slide to the right. Most of your code should live there, and very little of your code should live inside your Expo and your Next, because that's locked down. And you don't want to create circular dependencies. You don't want to have code that's in Expo that goes into your into your packages and that gets back out into Expo, because then you start touching Next code in Expo and Expo code in Next, and just keep things together. So what we want to focus now on is minimizing divergence using composable atomic components. And hopefully a lot of you will say, yeah, that's what we do, right? This is a best practice. So it shouldn't be anything new. It should just be helping you go, now I know why I want to build these composable atomic components, because this is what all of the to-dos, this is what all of the, getting started with a framework applications look like. But I don't know how many of you here are building simple sheds, right? And when I look at that, I think they really didn't build that on a very strong foundation. I don't know what's up with that ramp. This isn't something I'd be proud to ship. This is what my customers are usually looking for. And so when I start building an application, my customers expect that it's going to have to scale. They want to know that it's testable. They always want to know how many unit tests, what's your test coverage? Question I just don't like to have to answer. It's going to need to evolve as the brand changes. I believe in lean, agile processes. I believe that I don't know what the application is going to look like in 6 months or 3 months or next week even, because I want to build, measure, and learn. I want to go into a really iterative process so that my customer tells me what the application should look like and how it should function. I want my code to be well written. That's a personal thing. I'm a Perl programmer from back in the day, a big fan of Larry Wall, and his first tenet of a good programmer is lazy. You always want lazy developers on your team because we will write the code so well we don't have to do it again. I don't want to have to explain my code to people. I just want you to be able to look at it and go, oh, never happens, but that's the dream. We want metrics. How can you measure if your code isn't communicating and providing feedback to your business people to know what works? A/B testing, canary builds. How do we add that to our code bases when our code bases are already so complicated? And that brings us to logging. We want to know what's going wrong in the applications when they're in production so that we can monitor and we can see what's happening. We want visibility. And of course, most importantly, we want our customers to love our code base. How many times do we celebrate and go, wow, this is so amazing? And an incredible quote comes to mind by Dan Abramov, which is, stop building clever code. Customers aren't going to appreciate the intricacies of your magic when the app just doesn't give them what they look for when they're looking for it. If your user experience falls down, if it's not accessible, I would argue, what's the point? So we want our customers to love what we do. So speaking of apps that we would love, I couldn't think of a better app than Google Maps. Once again, I have nothing to do with Google Maps, except I use it extensively. And I use it on the web, and I use it in my browser. And I am very sure that Google does not use React Native. But that's okay. What we would like to do is look at the principles of our Google Maps and go, there's some things that we want to take away. Number one, the app should behave and look different on the two different platforms. It shouldn't be a web view that's jammed onto a mobile device. It's not going to work. So let's draw our attention over to the layers here. Our layers button is available to change some things, and you can choose different layers that you want to apply to your map. The same feature is found in our mobile device up in the top right corner. Slightly different buttons, but the same intent. If I click the button, I should be able to see some layers, whatever that intent is. So if we look at our application here, we can see in the website, it's a little drawer, slides out to the right. There's lots of room on my page, and I now have 5 choices. And I can click more. It'll open up, behaves quite nicely. It's what I would expect in a website. But I don't have the real estate on a device to do the same thing. So this is an experience you might see in a native build. Your drawer is going to open, or we have a slider that's going to open up, and it's going to give us similar intent, similar things that we can do that we can also do in the website. I want you to have a Where's Waldo moment. I want you to have a look at this slide because we've got a test in about 5 minutes. Okay, how do we do this with a hyper-hybrid architecture? When I look at code, including my own code, React and Angular and some of these frameworks have really put us towards this hyper-nested, hierarchical way of building applications. Why? It helps with prop drilling. I can pass my props down. I can have events trickle up, propagation. It's how HTML looks. So it feels natural. But in order to make our applications composable, my recommendation is to move to a flatter hierarchy or a flatter structure. We want to move our buttons out of the button container. We want to move our layer button itself onto our background. So when we activate that intent, the state can change in the application, and our drawer knows I need to slide out. There's separation of concerns. This layers button doesn't need to know what it's supposed to do. It just needs to know I was activated. It's up to the rest of the application to decide how to respond to the actions that you have initiated or that your customer has initiated. We call this declarative because we're declaring the intent. I have been clicked, I have been pressed, I have been scrolled. And it's up to the rest of the application to decide how to respond to that. And this allows us to move to a flatter architecture. But there's something else that we need to wrap our heads around before we can fully move into hyper applications, and that is code splitting. Most of the time when we talk about code splitting, we're thinking in terms of tree shaking. I want to reduce my bundle size. I want to have a better application by getting rid of code that I don't need in my bundle. In our case, we're going to be code splitting based on device type. So I can write some of my code and say, this is going to target iOS or Android, and some of my code that's going to target native. And I assume this would just work, and part of the reason is because I didn't bootstrap my very first Tamagui application, and it just worked. It was magical. And I fell down. And it took me a couple of days. And this is where Stack Overflow's your friend. These are the bumps in the road that I was mentioning. How to get things to work. And one of the challenges is that Tamagui and Expo and many of these frameworks are so new that we can't just look to the documentation, or we're not even sure which documentation to look at. Is it the TypeScript documentation? This answer shows that this is a TypeScript problem in the tsconfig JSON file. So use the tools that are available to you. Remember that there are other developers who have solved or are solving the very same problems you're solving. And I can tell you from firsthand experience, while working with Tamagui, my front-end developer spent time in Discord actually dialoguing with the creator of Tamagui and other of the senior developers in the Expo ecosystem to help him get over some of these hurdles. So reach out to the internet, and I just learned something about a week ago, and that is we can ask ChatGPT. We had a brilliant talk about AI. How do I do this? And ChatGPT can just churn through the internet and go, I can tell you how others have done it. So this is how I did it. This is what my tsconfig ended up looking like. And I just wanted to throw that out there so that you can see that this was a problem that I had. It took far too long to solve, and it turned out it was 3 or 4 words in a JSON file. So let's see some of this in practice. So I'm a makeup artist. I want to have a really beautiful website. So I went to my design team and said, hey, can you build me a new brand? And they said, here you go. Build this. I want to draw your attention to the part here that makes this look like our Google Maps. So the designer has got this bottom navigation. We've got the icons at the bottom, and you can see that the navigation for the website is up in the top where you would expect web navigation to be. We've also got at the bottom of our page, right where our thumbs are on our mobile device, where we want our navigation icons to be. And finally, we have a drawer that's going to activate when we click our hamburger menu that's going to give us further navigation. Now, my designer wasn't content to just say, here's the design files. He made me a video. This is how it's supposed to work. So now we have some idea that I can click the navigation items and go to different pages. When I click the buttons at the bottom, I get this really neat effect. And my thought was, well, how am I going to do that in React Native? But my designer, as usual, has got buy-in and sign-off. Now I have to build it. So our focus now is our face, eyes, and lips have to align in our web app and in our device. This demo is available in GitHub. It'll be on my last slide. So here's the code. The first thing I want to draw your attention to is deliberately making sure we create components as we build our applications. The last thing you want to do, a lot of companies now, they're buying component libraries. And I love this approach. It's like, I'm going to build a component library as I build my application. I'm going to deliberately build component architecture, these atoms and molecules we mentioned earlier. So here they are. Our top navbar and our bottom navbar are basically going to do and look the same. The glue that's going to glue them together is TypeScript. So we had a great talk earlier about TypeScript and why we want to use it. It's going to help our browser help us, but it's now going to glue together different components that need to behave the same way, but in different environments. And if I go and change the signature in my mobile application, my web application is going to say, whoa, I need that change too, because TypeScript. So there's our interface. The navbar interface is on both components. And then you can see I go back together with my glue, and my main nav items are both reflected in each of the applications. Here's the test for Google. Did you spot the differences? And not to be critical, Google's an amazing company, but I actually had to Google bicycling. I didn't know what that was, because I live in Canada and we cycle in Canada. In fact, biking is something you do on a motorbike. So it was kind of interesting to me that Google has discrepancies between its localized content and its unlocalized content, or however they came about it for web and devices that are a little bit different. And most people would probably not notice unless they're compared side by side, but we want to avoid that. So this is our nav items props and our component. We've got our face, eyes, and lips. Yes, I didn't have time to put in full localization and import tags for text, but that's something to be, we would add, and we could do it in one place. So the key here is our component, our common code is predominant through the application, with the occasional diversions where we need to do a layout change for our web or for our mobile. Tamagui provides an isWeb function, which I would recommend avoiding as much as possible. But if you have a very small change, use isWeb. And in this case, our image icon, our picture icon, is toggled using isWeb so that I can throw on the web or on my device a simple image, and on my web architecture I can throw a picture with source and all my media queries so that things continue to render well. As I try to wrap up really quickly, I want to finish by talking about the future of Tamagui and why I believe it's an evolving solution and why I would love to see you embrace it. And this comes down to what I call the JQuery predicament or precedent. Rezig, when he developed JQuery, said writing JavaScript code should be fun. And one of the things that we realize about JQuery is that JQuery isn't standalone. It's about 70% of the internet has JQuery on it. But JQuery is the culmination of many different platforms. And I couldn't list them all, but YUI was big. Prototype was one I adopted early. Sizzle, which is actually built into jQuery and into Prototype. So there was a lot of collaboration and a lot of working together. Dojo is another alternative to jQuery. But the problem they were trying to solve was the browser wars. And today we have device wars. We have Kotlin and Swift and iOS and Android. And throw into that mix www, and we're costing our businesses money trying to build three separate and maintain three separate code bases plus our back end. Wouldn't it be great if we could build one application in one language that was cohesive and integrated so that we didn't have those odd little mistakes where localization was inconsistent, and that it was fun to work with? I suggest that Tamagui offers us a solution to that problem, and this is the key, one of the key takeaways. There is light at the end of the tunnel. Tamagui presents us with a very powerful solution. Is it there yet? I would suggest not. Is it Tamagui that's going to eventually solve this problem? I don't know. But Tamagui is built on top of an ecosystem that includes Expo, React Native, and even to some degree Cordova, PhoneGap, all of the early write once, run everywhere frameworks. And of course, JavaScript, which I include Next.js and React and that inside JavaScript. So it is the tip of a new iceberg that we're emerging. So thank you very much. I hope you'll join me in this journey. And the last thought I could leave you with is, if you would like to complain about Expo or Tamagui and all of the road bumps, write a PR instead. Thank you.
That's great. You want to join me over here? All right. So, I like that. They're a little skittery.
It's a skate chair.
So, you use that JQuery metaphor as you were wrapping up there, and I would love it if you could just maybe dive a little bit deeper into that. Can you just dive a little deeper into your JQuery metaphor?
Sure. JQuery gets a lot of hate, and that bothers me. And the reason it bothers me is, as I mentioned at the beginning, my first program I wrote on bubble cards on a Fortran PDP 100 terminal. And it was in grade 10 math class, and I couldn't tell you how to write Fortran today. But it was a foundation, just like Perl would become a foundation for PHP, which has become a foundation for dynamic languages like JavaScript. So to dismiss JQuery and say, JQuery is this terrible language, it did everything wrong, well, how do we know it did things wrong? It's because it did it. And so we can become really discouraged with the predecessors and say, we've got so much better, but that so much better was built on a lot of hard work by a lot of really good people. So I really don't like the jQuery hate. We were talking about WordPress in the lunchroom. WordPress is another thing that made me a lot of money before I knew what I wanted to do. And I look back at that and go, I learned so much. And you don't get best practices by writing the best code. You get best practices by watching what emerges, what surfaces. So what I would really like us to take away from the jQuery analogy with the Tamagui analogy is we can be really critical of the problems that we see. And as I end with, rather than being so critical and complaining about it, submit a PR, get in touch with the developers, talk to them, find out why they did things the way they did. And hopefully we can learn a lot from it and we can build a better ecosystem.
I like that. I think, especially with something like jQuery, it's definitely a little short-sighted to think of jQuery as being bad, because so much of jQuery ended up built into the platform. Right? It directly informed how we use document.query selector and a lot of these tools. So I think that some of the issue is that tools are here to serve a purpose. You use jQuery when the browsers don't align, when the browsers adopt the best ideas from the community, and then you don't need jQuery anymore. And that doesn't mean that it's bad, it just means that it served its purpose. And it sounds like we're maybe in a moment where we need that for unifying this experience between native apps across different platforms and the web. Mm-hmm. So I have Jessica. Jessica asks, have you experienced any Tamagotchas that you can share?
I have. And that's exactly what I mean by road bumps. Interestingly enough, one of the challenges of a vertical stack, and it's hard in 30 minutes to try to really deep dive into it. When you start at the top, you npm install Tamagui at latest. Well, that doesn't mean that Expo comes in at latest. Mm. That doesn't mean React Native comes in at latest, because Expo is bringing it in. So now you have documentation hell, and if you're a framework developer, please version your frameworks. Versioning is so critical to understanding the changes in the changelog. And in our application development, my front-end developer, he kept saying, half the time I've been working on this, I've been in the changelog trying to figure out why an Expo library has stopped working. And it's like, oh, I just realized Tamagui is using Expo 47 and we're on Expo 48. So yes, there are a lot of, as I say, the water's warm, jump in, but the waves just make it more fun.
That's a healthy outlook. I think that's, yeah, we could all maybe embrace that a little bit, you know, and say, it's not chaos, this is excitement.
Yeah.
All right, so here's a question. Expo comes with the toggle to distinguish between platforms like web and mobile. It seems useful, so why not recommend the isWeb toggle for Tamagui?
Wow. Tree shaking. Now, again, I haven't done a whole lot of bundling and performance optimization and really digging into it. One of the challenges, and where isWeb really comes in handy, one of the probably the biggest places where I found isWeb is helpful is an annoying little bug. Actually, that was part of the answer to the previous question. React Native doesn't handle calc in CSS. But it's so easy to put in a web media query and go calc 100% minus 110 pixels. That was my last one. And that works. It works great. Now, in most of the time in native, you just need 100%. So you end up with an isWeb calc, otherwise 100%. And it just feels right. But it's tiny. But if you have a lot of if statements and big blocks of code, your code base immediately starts growing. And if those two code bases are quite different, A, how are you going to tree shake that nicely? You're asking a lot of your bundler, but you're also writing big, hard to manage, less scalable code. So take the isWeb out, use the extension, and build your code in two separate files. And now when one of those files needs to modify, you don't have to worry about where in the file you are. So you're making your life, your future self's life, easier.
So you're clearly very excited about Tamagui. At work, is Tamagui widely adopted across all teams and projects, or do you find that it is kind of each team is choosing their own adventure?
So Tamagui actually came to me from our company's CEO as a technology that we wanted to dive into. We had an opportunity on a product where we had free reign, so that was something that we wanted to look into. And we do have a number of developers at Rangle who are exploring Tamagui as a, I knew I was going to do that, as a potential solution. I've played with a few of the other solutions, and by far, I think, like my recommendation is this framework has the most complete way to go. Now, something I didn't mention, it's brand new to me. I was listening to Nate at ViteConf, and he brings up something called local first development. And that's mind-blowing. Local first development is the concept that you should be able to use an application when you're off Wi-Fi, when you're disconnected from the internet. And I'm a big believer in that because I like to go camping and use my phone, and I don't know why I need to sign into something that doesn't need, and it's like I can't use my fingerprint. No, I've got to go through an email solution, and I can't because I'm camping for no reason. So I'm a really big advocate for local development. I didn't know what it was called, but Tamagui is moving in that direction as its creator moves in that direction. So for me, that's also a really exciting, future-facing feature of the framework that I'm excited about.
Yeah. And so we started after the lunch break about 5 minutes late. So we're going to go about 5 minutes over here to make sure that we don't cut you off on the Q&A. But that will mean that our break is going to be a little bit shorter. So I really like this question. Given that browsers are investing a lot of support in progressive web apps, does something like Tamagui give us extra that a progressive web app build doesn't?
Yes, it gives you native. So that's the flippant answer. To give you a better answer, when you're building the web side of a Tamagui application, you're really focused in Next.js. So the answer there is you're in Next.js world, you're using Next.js concepts. It has SSR built in. It has an API layer, which as I say, I didn't really recognize until I started building with Tamagui and going, how am I going to just get data? All I want is data. I don't want a rendering or a generated code, as I prefer to put it. I want a little bit of data, and I want it fast. So I don't want the overhead. And Next.js has that as well. So I think progressive applications for the desktop, when a person's connected to a wireless net, like they got Wi-Fi, they're on a network, it's great. You're going to get a faster user experience. I'm a big fan of Module Federation, which is an alternative technology where you can progressively load your applications. I think all of these technologies have a bright future, but when you're going to do native, put the app in my phone, please.
Gotcha, gotcha. That's actually, so my general approach to like web and native has been to focus on one, because historically the compromises of trying to build a one-size-fits-all requires so many trade-offs that you kind of end up with a almost good version of both instead of a really good version of one. Do you feel, because it's been a long time since I've tried to do this, so do you feel that in the recent years that has changed and you can build, using something like Tamagui, a really good experience that delivers to both web and native?
I think that's going to really depend on our design teams. If our design teams can think in terms of component architecture, and I think Figma is pushing that narrative, it's helping in that space, because as a user, I like consistency. I like to be able to look at a button and go, oh, if I push that button, this is what it's going to do. I find sometimes Google can be a little bit funny. I go to my email and I'm like, where's the button? Oh, it's over here. Why is it there? That doesn't feel right. But then I go on my phone and it's like, why is the button up there? You got it backwards. So getting our component library, and this is why I really focused on componentization, allows you to build a lot of the pieces that you're going to put together in a cohesive manner that have really common theme. The localization text is right. Your area labeling is all correct. You've built it once, and now you can assemble that where it needs to be. And I really hope that those slides tried to bring that out, that they can be in completely different places, they can have different treatments, but in effect they're the same thing. They're going to open up drawers with commonality and familiarity, but with the feel of the platform you're currently on.
Gotcha. Well, Ken, thank you so much. That's all the time we have for. Everyone give one more round of applause for Ken. All right, now we are going to take a 10-minute break this time. So we'll see you all back here at 1:45.